Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be doing the GFG Weekly Coding Contest 88 post contest analysis. So, basically, after a lot of requests to the problem setters, they this time set the problems to a very good level. Like they were very standard, to be honest, and they were very up to the mark. No more wrong test cases. The problems were absolutely the great one. So can I have a quick yes or no if you are in the stream? Just a quick yes or no. So when I started off this like what was the date, let me just see. Yep. So when I started off this interview series, like last on 1st of Jan, this year, I was streaming. Okay, so basically, I told that yes, this time I would keep a beard. So I too want to know how it is looking. So basically, hi Pavni, hi Abhishek, hi Biological, hi Abhishek Rao, hi Cyberinfo.org. Okay, fair enough. So we would start off in a time frame of around 30 seconds, and we would move forward. Okay, so this time, what is the review? Like on a scale of 1 to 10, on what basis you would rate the problem? Like 10 means good enough or the best one, and 1 means like it is not up to the mark. Okay, below 5 is not up to the mark, above 5 is good enough. So on a scale of 1 to 10, I too want to know how much. Like this time, I liked the problem set. So very first problem we would be doing is range or, which was a easy problem, then the max array, where the intuition was intuitive. Okay, and we could have come to the solution. Okay, if we are to return the array, but we need to return the max array. So it was a very easy one, but detecting the time complexity, yes, this would pass. So this was a little bit different. Equal grouping was a problem which I liked very much. Okay, like when I drew it down on a pen and paper, um, so I thought that yes, this could be done. Okay, so now we would start with the very first problem. I would give you a 30 seconds to read the problem, and then we would move forward with the very first problem. So Chrome tab, range or, and we are done. Yup. So this is the problem that you are given. So hi Manya, hi Hari Prasad, hi Tej. Better than the last contest. Yes, absolutely. To be honest, this time the problem set were absolutely the great one. For me, this is the best contest. Okay. Hi Ronak, how are you? Okay. So I think this is fine. So now let me just start the explanation. Oops. I was about to end the stream. Hi Utkarsh, how are you? Yep. So, yep, now we go and we are about. Yes. So now, this problem, if you see this problem, what you need to do is you are given an integer n and you need to find the bitwise OR of 1 to n. So, bitwise OR means 1 or 0 is equals to 1, 0 or 1 is equals to 1 or 0 is equals to also 0, and 1 or 1 is also equals to 1. This is the truth table of OR. Okay, basically if either of the bit is turned on, the answer would be a set bit. If both the bits are off, the bits would be a turned off bit. Okay, so now we are given 3. The very first one would be 1. So 1, then 2, which is equals to 1 0, and this is equals to 1. So now if we do the bitwise OR, then 1 or 0, 1 or 0 is equals to 1, 1 or 1 is equals to 1, 0 or 1 is equals to 1, 1 or 1 also equals to 1, which is equals to 3. That is why the output to this is 3. So basically, if you see the problem for a number 5, if n is equals to 5, okay, so we are given 1, then we are given 2, then we are given 3, then we are given 4, and then we are given 5. So basically, if you just see, either of the bit is turned on, so it would be turned on, on, 1, on. So basically, if you just see, the bits we need, and above that bits it is 0. So if we can somewhat find the position of the highest bit, then we can just turn it off, and all the bits on the right hand side would be turned on, and all the bits on the left hand side to that would be turned off. Okay, so this problem is a very easy problem, like n is equals to, let's suppose, 8. So we can say it is 1. Okay, then the next one is 1, 2, 3, 4, 5, and then 6, and then 7, and then 8. Okay, so basically, if you just see, this would be turned on, 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 and before that, everything would be 0. So what we need to do is, we need to find this position. We need to find this position. How this position can be found out? Basically, this is nothing but log base to n. Okay, or what we can do is, we can simply divide the number by 2. It can be divided once, so 2 to the power 1, 2 to the power 2, 2 to the then 2 to the power 2. Okay, 2 to the power 3. So basically 2 to the power 3 is equals to 8. That is why 8 can be divided 3 times. Okay, so this is how we would do it. We would just keep dividing the number by 2, or we can just do log base to n. Okay, and then we can just subtract one number, we can find this value. So what is subtracting one number? So if we just see the binary representation 0, 1, 2, 3, yes, the binary representation of 8 is this, and if you subtract 1, that is 7, then it would be like this. So then again, binary representation of 16 is like this. If you subtract one number, this is 16, 0, 1, 2, 3, 4. If you subtract one number, the one would be like this, 15. Okay, 2 to the power 0 added to 2 to the power 1, 2 to the power 2, 2 to the power 3. That is 8 plus 4 plus 1. Okay, plus 1. This would be 2. So 8 plus 4 is equals to 12, 12 plus 2 is equals to 14, 14 plus 1 is equals to 15. So yes, this is correct. So basically what we can do is, we can find the highest power of 2, subtract 1, and that would be our number itself. So now we would move forward to the implementation. Chrome tab. Hi Inspiration. Hi Harsh Rajput. Hi Danish Khan. Please don't send solutions at this point. Okay. Please don't send solutions here, because I am here to send the solution. If you send the solution beforehand, then I won't be able to tell you the intuition behind it. Like when you receive it in a contest, how you, because the solution is not at all important. You can just click here and go to full solution and you can find the solution, but this is not important. The important thing is how to solve a problem when we receive in a contest. So we would start from 1, and we would say, while the answer is less than equal to n, we would start multiplying the answer by 2. Answer multiplied by is equals to 2, and then at the end, whatever is the value, we would do answer minus minus, and then we would return the value of the answer, just so that 8 minus 1 is equals to 7, where all the bits would be turned on. 16 minus 5 1 is equals to 15, where all the bits is turned on. So whenever you receive this problem, you write it down on a pen and paper, solve it for different test cases, and that would give you the solution. So just compile and run and see how many errors are we making. Okay, seems fine. And we have solved it. So quickly tell me the line number at which you are not able to understand, and then I would explain you. Can you please explain it again? Yes, absolutely. See, what we did is that we write it down in a pen and paper. Okay, like we just did. Stop the screen sharing. And then the entire screen. Okay, so see, we just tried to solve it for n is equals to 5. When we saw n is equals to 5, either of the bit is turned on, either of the bit is turned on, either of the bit is turned on. And we found out that all the bits on the left hand side of this position is off, and all the bits on the right hand side of this is on. So basically what we can do is we can find the highest power of 2, subtract 1, because 8 minus 1 is equals to 7, and the binary representation of 7 is like this, and the binary representation of 15 is like this, binary representation of 7 is like this. So basically translating the same in Hindi so that people would have a better understanding is what we are doing is we are just हम लोग सारे नंबर्स ले रहे हैं, हम लोग दूसरे इनपुट के लिए चेक कर रहे हैं, जब दूसरे इनपुट के लिए लिख रहे हैं तो हम लोग देख रहे हैं कि जब एक भी ऑन है, ओके, बेसिकली इफ एक भी ऑन रहने से हम लोग क्या कर रहे हैं कि सारे को 1 दे दे रहे हैं, तो हम लोग हाईएस्ट पावर ऑफ 2 निकाल रहे हैं, -1 कर दे रहे हैं, क्योंकि -1 में सारे बिट्स टर्न ऑन होते हैं. अब उसी को हम लोग एज अ आंसर रिटर्न कर देते हैं. ओके, one question: why C hash language is not available? Just mail me over. Why does it not accept? But I have used bitwise operator. See, I have used bitwise operator, and you can use bitwise operator, to be honest. Okay, so now the next problem, which is a very interesting problem. Okay, so now let us first discuss what is max. Okay, so max is the smallest, so am I visible? Yes, smallest non-negative value that is not present. Okay, suppose if the given value is 1, 2, 3, then the max of this array is 0. Now suppose we have 0, then the max of the array is 4. Now suppose we remove this 1, then the max of the array is 1. Okay, the smallest non-negative value which is not present. Suppose 1, 2, 3, everything is present, then the max of the array is 4. Okay, so basically this is known as the max of the array. Now what we are told is, we are told okay, now we are told that we are given an array like this, and you are allowed to rearrange the elements. Okay, you are allowed to rearrange the elements, and you need to find the lexicographically smallest array that can be obtained. Okay, lexicographically smallest array that can be obtained. So suppose we have 0, 1, and 2. Okay, 0, 1, and 2. So the max till this part is 1. Okay, the max till this part is 1. The max till this part, 0 and 1 is done, so it would be 2. So 2, the max of this array 0, 1, and 2 would be 3. So now suppose what I do is I write the elements like this: 2, 1, and 0. So the max of the array till this part is 2, because earlier we have 2. So first non-negative value is 0, which is not present. So 0. Then we come across 1. 2 and 1 is already present. Is 0 present? No, 0 is not present. We write here 0. Then we write here 0. So 0, 1, and 2, everything is present. So it would be value 3. That is how this output is coming in. Am I clear with the sample test case? Give me a quick 1 in the chat if I'm clear with the sample test case. If I'm clear till this point, like like you are with me till this point, give me a quick one in the chat. Give me a quick one if I'm clear till this point. Today I won't drag the stream to a great level. Okay, thanks sir. Kamya Verma. Okay, what about others? What about others? There are 53 people. So can I have a quick like at this point? A quick like to the video would solve the purpose. Quick like. Let me see the like thing going up. Okay, so I would explain you again. So see, here we are told that we can rearrange the elements. Okay, so let us just see. See, first what we can do is we can reorder the elements. Reorder the elements. After reordering, we should reorder the elements in such a way such that the max is lexicographically smallest. What do you mean by lexicographically smallest? This just means that in the dictionary order, it should be the smallest one. Like let's suppose we have 0, 1 and 2 and then 1, 2 and 0. So after 0, we have 1. Just like we have, suppose we want to find ABC. So we have ABC in the dictionary, then B, C, D in the dictionary, then C, B, A in the dictionary in this order. So in the same manner, this ordering is preserved. So we want the lexicographically smallest string. Okay, so now we talk about how to get the lexicographically smallest string. So what we can do is, if we reorder the element 0, 1 and 2 to something like this, 2, 1 and 0. If we reorder the elements like this, then the max till the first element, no elements from the right would be taken, all the elements from the left would be taken. Like सिर्फ 2 है, so is 0 present? 0 present है कि नहीं? नहीं, 0 तो present नहीं है अभी तक, so first negative element ही present नहीं है, तो इसका max is 0. Next we have 2 and 1. 2 and 1 is present, but do we have 0 present again? No, we don't have 0 present again. So this time we have, up till this point, we have 0 also present, 1 also present, 2 also present. Is 3 present? No, 3 is not present. That is why after rearranging, this is the lexicographically smallest string. Okay, now tell me if I'm clear till this point or not. Kaushik, Tanushri, Ronak, Kamya, give me a quick yes or no. Can you take another example? Yes, absolutely. I would take another example. But doing another example would tell you the sample, like would tell you the solution itself. Let me see the like. Please increase the like counter, please. Let us see the like counter to be increased. Hi Praveen, how are you? Are we adding 1 and 2 to obtain that 3? No, we are not adding. We are finding the max. Why are we ordering it? Because we are told that we need to find the lexicographically smallest. So see, we are given an array, and what we are told? We are told to find the lexicographically smallest max array. And to do this, we are allowed with the operation of just reordering the element. Like एक array है जिसका लेक्सियोग्राफिकली स्मॉलेस्ट हमें चाहिए, और ये चीज पे जाने के लिए हमारे पास सिर्फ एक ही ऑपरेशन है जो है रीऑर्डरिंग. मतलब हमारे पास रीऑर्डरिंग छोड़ के और कोई ऑप्शन नहीं है. ओके, सो हम लोग एक ही चीज कर सकते हैं जो है रीऑर्डरिंग, और कुछ नहीं कर सकते. हमारे पास सिर्फ एक ही वेपन है कि हम लोग एक एलिमेंट का पोजीशन दूसरी जगह कर सकते हैं. बस यही है. दैट इज व्हाई वी आर रीऑर्डरिंग, और कुछ नहीं है हमारे पास पोजीशन. Now am I clear? So now Just see. Whenever we have a max array, okay, suppose we have 0, 1, and 2, 3, and then 4, and then 5. Suppose the given array is like this. Then the max till this point is 1. The max till this point, 0 and 1 is already present. So first non-negative element that is not present, it is 2. The max till this point, 1, 0, 1, and 2 is already present. Max till this point is 3. In the same way is 4. In the same way is 5. In the same way is 6. So what can be, this is not the lexicographically smallest. So this is the max of the array. This is the max array. Okay. And we want to minimize this. Lexicographically smallest करना है. Dictionary order में सबसे छोटा वाला चाहिए. So can we do better than this? Yes, we can do better than this. How? Let me tell you. Suppose 0, 1, 2, 3, 4, 5, if we reorder it to something 5, 4, 3, 2, and 1, then the max array from 5 is present, but is 0 present? No, 0 is not present. Is 0, like this would be 0, like if we flip it, is 0 present? No, 0 is not present. Is 0 present? No, this is not present. 0 is not present. 0 is not present. Now 0, 1, 2, 3, 4, 5, everything is present. So the max of the array is this. So now if we remove these two original arrays, okay, same array ka max hai, okay, this is the max of the same given array. Okay, now which is better, which is smaller, 1 or 2? Which would be lexicographically smaller? मतलब dictionary order में 1 पहले आएगा या 2 पहले आएगा? Give me the answer to that. Give me the answer to that. In the lexicographical ordering, how to find the max then? So we would just check, like till suppose we have 0 and 1. So we would start from 0. 0 is already present. 1 is not present. 2 is not present. So 2 would be this. Okay. Ruth, am I clear? Ruth Z. Black and white, I deserve a chocolate from you. 2 would come first. Tanushri, I deserve a chocolate from you too. Okay, fair enough. Harshit Choni, see, you need to give time. If programming was easy, every other person out there would be a coder. Coding is hard, and you need to accept the fact, and you need to keep going. Okay, so now we move forward. So now, as we can see, that if we reorder the elements 1 to 3 to 3 to 1, then we have a better answer at each step. Okay, like if the given value is 1 to 3, and if we flip it 3 to 1, then we have a better answer. So in the same manner, what we can do is we can simply sort it and then reverse it. Sort it and then reverse it. What is the intuition behind that? The intuition behind that would be, suppose we have 0, 1, and 2. So if we already have 0, then the first value would be 1. But if we keep this 0 at the very end, then we can't find here 0, we can't find here 0, we would find 0 at the end. That means 0 would be here, 0 would be here, and this would be 3. मतलब समझो कि क्या होता है जब मैक्स एरे है. मैक्स एरे मतलब क्या? स्मॉलेस्ट नॉन नेगेटिव वैल्यू दैट इज नॉट प्रेजेंट. सो पहले एलिमेंट पे अगर वो स्मॉलेस्ट वाला चीज हम लोग उठा के सबसे लास्ट में रख दे तो वो स्मॉलेस्ट वाला चीज नहीं मिलेगा, और पहला स्टार्टिंग में हमें स्मॉलेस्ट वैल्यू मिलेगा. दूसरे में अभी भी स्मॉलेस्ट वाला गायब है तो दूसरे में भी स्मॉलेस्ट मिल रहा है, तीसरे में भी स्मॉलेस्ट मिल रहा है. स्मॉलेस्ट हमें तब तक मिलेगा जब तक हम लोग लास्ट तक नहीं पहुंच जाते. सो स्मॉलेस्ट वाला वैल्यू अगर हम लोग लास्ट में उठा के फेंक दे तो स्मॉलेस्ट वाला वैल्यू स्टार्टिंग में दिखेगा ही नहीं. इसका मतलब स्मॉलेस्ट वाला वैल्यू ही मैक्स होगा स्टार्टिंग के सारे पोजीशंस के लिए. अगर स्मॉलेस्ट वैल्यू स्टार्टिंग के पोजीशंस के लिए मैक्स होगा तो डिक्शनरी ऑर्डर में वो हमारा ऊपर रैंकिंग करेगा, which is beneficial to us, which is what we want. Am I clear with this? Like we would simply sort it, reverse it, find the max, and then we return it. Now, am I clear with this idea or not? Give me a quick yes or no. Am I clear with this idea? Okay, what about others? What about others? There are many people at this point. So there are 60 people. Can I have at least the number of likes equal to the number of viewers right now? Can I have it? I'm trying my best to explain. Can I have at least 60 likes? Okay, I'm clear till this point. Why? Why? Because number of likes and the number of comments and the number of appreciation is equal to the impact I am able to make as an educator being here in Geeks for Geeks. So it increases my ranking of reputation. Okay. Max array. So what we would do is we would simply take down this. We would sort a comma a plus n. Okay. And then we would reverse it. A comma a plus n itself. After reversing, we would say initially the max of the array is 0. Now we would simply hash it. So first we would have a vector of int b. This would be the answer. This would store the answer, or what we can write is answer, and that would solve the purpose. Answer array. And then we need to hash these values. Like अभी तक हमारे पास क्या है? Like suppose 0 and 1 is present. So पहले हम देखेंगे 0 present है कि नहीं, 1 present है कि नहीं, 2 present नहीं है, तब वो value. So suppose we already have 0 and 1. So we would first go to 0. If 0 is present, we would search for 2. If 2 is present, then we would search for 3. So searching if the element is present or not. So if we want to search if the element is present or not, then what we need to do is we need to hash the values. So we would make an array of size 10 to the power 5 plus 5. Why? Because we know that the elements can be till 10 to the power 5. Okay. So we have made an array. 10 to the power 5 plus 1 would solve the purpose because the indexes are 0 indexed, and we would initialize everything with 0. Then we move forward and we start hashing the values. Okay. So for int I is equals to 0, I is less than n, and I plus plus. And then we would say f of a of I plus plus. Okay. And then we would say while जब तक हमारे पास ऐसा कोई नंबर नहीं मिल जाता, we would start from 0 and we would go till the point where that particular value is not present. Okay, so we would say while f of ind is not present, while f of ind is not present, we would simply do ind plus plus. We would keep doing this. At this point, we already have a value which is not present. So that would be the max. So we would insert it to the B array. At this point, we already have the B array, and then we would return it. B was not declared. Okay, so we would just make this as B. B is the array. Okay, we are getting correct output. And we are done. Okay, so now tell me the line number, the point at which you are not able to understand. Okay, can you write in Java? Is there an approach with less space optimization? Yes, absolutely. Basically, what you can do is you can insert everything in an unordered map. But what happens is unordered map has a worse time complexity of big O of n for each case. So that is why when solving problems in an online judge, problems in an online judge, don't really care about spacing. Okay, what is f here? F here is the frequency array. We are adding the frequency, like yes, this value is present plus plus, yes, this value is present plus plus. Okay, line number 26, why this is present? So see, suppose we already have 0, 1 and 2. So first we would search for 0. 0 is present. Okay, so IND is equals to 0. 0 is present, so we would increase one value. 1 is present, so we would increase one value. 3 is present, 2 is present, then we would increase one value. 3. 3 is not present, then we would insert this value to the bth array. So this is just like finding the max. Okay, am I clear to you, Kamya? Rajendra, am I clear to you? Contest में please improve कर दो problem बहुत badly explained. So see, to be honest, if the if the problem explanations were given good enough, then it would lead you to the solution. That is why the problem explanation is done. Bro, can you use reverse sort? Yes, absolutely, I can use reverse sort, but sorting and then reversing, it would make the explanation easy for Java coders also. That is why I felt more explanation is needed during the contest. अभी क्वेश्चन समझ आया. Thank you so much. Worst time complexity is n log n, because we are sorting it and then each point we are just searching it, not n square. Am I clear till this point? Give me a quick one. So this is after a very long time. This is the first time in a time frame of 30 minutes I have finished the explanation of the first two problems. Now the only remaining one is the last problem, which is equal grouping. I'm getting the answer as 3 but unable to add 0 in the array. So just send me this. Array Gaurav Lakwani, I understand. Thanks a lot, Gaurav Lakwani. What about others? 10 to the power 5 ही क्यों डाले हैं? Because see, हम लोग एक बड़ा, so we are taking a very big array where we can hash the values. Okay, so at max the values of the element can be till 10 to the power 5. That is why to hash the values according to the index, we are taking a value 10 to the power 5 plus 1. Okay, what about others? Quickly give me a reply. So now the hoodie season is going off, and now I can again wear this same old black t-shirt. People generally ask me that, Bhaiya, you always wear this black t-shirt, don't you wash it or something? Okay, fair enough. I'm done till this point. Now comes the last part. Okay, chalo, let's move forward to the last part. So for the last part, kindly read the problem for 1 minute. Kindly read the problem for 1 minute. So we can also make frequency array of n plus 1, sir, as per the constraint. Yes, absolutely. You can. Your smile is inspiring. Thanks a lot. Okay. Thank you so much. But I think so. I would leave the mentor thing in GFG soon. Think so. Like, I don't really know, but I need to make a decision of that. Okay. So are you done reading the problem? Give me a quick one. Why? There are some problems associated with this. Okay, so when you're done reading the problem, give me a quick one in the chat. So more than 5 requests in the comments to for me to not leave GFG, and I would be there in GFG, and I would continue in GFG. It has been around 2 years since I am with GFG as an educator. Okay, fair enough. I think it's done. Okay, let's move forward. Mhm. What if one comments to say go then? No, not here. In the comment section. So in the comment section, if I receive more than 5 comments to not leave GFG, and I would stay there. So I would see the comments. Okay, chalo, let's move forward. Okay. So now, in this problem is, to be honest, very interesting. And if you write this down in a pen and paper, you would solve it. So see, easy and medium problems have a very easy property to track down. What the property is, that if you write down the sample test cases, how we are coming to the solution in a pen and paper, then you would be absolutely the one solving it. So now see, it is told that integers belong to a particular group if it is in the range of 2 to the power I to 2 to the power I plus 1 minus 1. Let us see what is this. So suppose 2 to the power I and 2 to the power I plus 1 minus 1. Suppose if I is equals to 3, then this just means that 2 to the power 3 is equals to 8 and 2 to the power 4 is equals to 16 minus 1, which is equals to 18 till the value of 15, and both are inclusive. Okay, 18 till the value of 15. Suppose I is equals to 2, then it would be 2 to the power 2, which is equals to 4, 2 to the power 3, which is equals to 8, 8 minus 1 is equals to 7. So this just means that we can go from 4 to 7. Okay, suppose I is equals to 4. Okay, then 2 to the power 4 and 2 to the power 5 minus 1. This just means that 16 till 2 to the power 5 is how much? 2 to the power 5 is equals to 32. 32 minus 1 is equals to 31. Okay, so we can see that the numbers from 8 to 15 belong to the same group, 4 to 7 belong to the same group, 16 to 31 also belongs to the same group. This is what it is trying to tell us. So now if we go back, we are given an array, and in one operation you can select a subarray of even size. What do we mean by subarray? Subarray is basically a part of the array. So we can say that 2 3 is a subarray, 1 2 is a subarray, 3 4 5 is a subarray, the whole array is a subarray, a single element is also a subarray, and 4 and 5 is also a subarray, 3 is also a subarray, the whole array is also a subarray. So basically subarray is nothing but a part of the array. So in one operation you can select a subarray of even elements. Okay, and you can delete that element. So suppose we have 7. So let us take this. Okay, let us take this value, and then you would understand what I'm trying to say. Okay, so we already know that, so let us have this 2 to the power I to 2 to the power I plus 1 minus 1. So 2 to the power 1 is equals to 2, and 2 to the power 1 plus 1, that is 2. 4 minus 1 is equals to 3. So 2 and 3, one group. Then 2 to the power 2 to 2 to the power 2 plus 1, that is 3 minus 1, which is equals to 4 till the value of 7. Okay, and then 2 to the power 3 comma 2 to the power 4 minus 1, which is equals to 8, and 2 to the power 16 minus 1 is equals to 15. So we have the groups as 4 to 7, 8 to 15, 2 to 3. So basically if you see that 7, 8, 6, 4. Okay, so we can say that we can remove 7 and 8. 7 and 8 don't belong to the same group. Okay, so we can say 4 and 6 belong to the same group, because 4 to 7 we have the same group. So 4 to 6 belongs to the same group. and 7 belongs to this group and 8 belongs to this group. So they both belong from different group, and we can't select one element. We either need to select even number of elements. So this is not possible. So remaining length is 2. So that at the end the remaining value is 2. This is how the solution is popping up. Let's see the next one. Add to the current page. Then we will just remove everything. Okay, now see, we have 172. So 172. 1 belongs to 2 to the power 0 till 2 to the power 0 plus 1, that is 2 minus 1. So 2 to the power 0, 2 to the power 1 minus 1. That is equal to 2 to the power 0 is equals to 1, 2 to the power 1 is equals to 1, 1 minus 1 is equal to 0. So this belongs to the first group, 7 belongs to the next group, and 2 belongs to the first group. Okay, that is this one. 2 belongs to this group. So everyone belongs to different groups. Okay, this is belonging from the first group, this is second group, this is third group. Like we have the first group here, then 7 belongs to this group and 2 belongs to this group. So every group is different. So each element is from the different group. So no even order, no even grouping is possible. So we can say that we can't really remove elements. So the remaining number of element is 3. That is why 3 elements are remaining. So am I clear with everything or not? Give me a quick one in the chat. So not here. The number of comments in the comment section I would see, then I would decide if I need to leave GFG or not. So give me a quick one if the test cases are clear. Subarray should be clear. Okay, subarray should be clear. Then the formula 2 to the power grouping should be clear. Okay, and the removal of element should be clear. Give me a quick. How should I take the ith value? So this just means that 2 to the power I to 2 to the power I plus 1 minus 1. So I can be anything. I can be equal to 1, I can be equal to 2, I can be equal to 3. Okay. So everyone clear with this? A person who is not clear, give me a 0 in the chat and I would explain you again. Okay. Fair enough. Thanks a lot, Kamya. I think only one is sufficient. Okay. Fair enough. I think we can move forward. Okay. Yes, every value. Priyavada can. So I would just tell you what this is all about. Okay. So just a quick recap. So see, it is told. So see, it is telling us that they both belong to the same group. Suppose I is equals to 1, then 2 to the power 1 till 2 to the power 2 minus 1. That is equal to 2 to the power 2. 2 to the power 2 is equals to 4. 4 minus 1 is equals to 3. If suppose I is equals to 2. So 2 to the power 2, 2 to the power 2 plus 1, 2 plus 1, 3 minus 1 is equals to 4. 2 to the power 3 is equals to 8, 8 minus 1 is equals to 7. If suppose I is equals to 3, then 2 to the power 3, 2 to the power 4 minus 1 is equals to 8 till the value of 15. So I can be taken as anything. So it is just telling us that 2 to the power 8, 2 to 3 एक group में रहेगा, 4 to 7 एक group में रहेगा, 8 to 15 एक group में रहेगा. This is group 1. If there is a value known as 2, it would fall into group 1. If there is a value 5, 6, 4, then it would fall into the second group. If it is 9, 10, 8, 11, then it would fall into the third group. Am I clear? The two people, Priya Yadav and Fatima Nuha. Am I clear? Just give me a quick one. Fatima Nuha and Priya Yadav. Am I clear? Just give me a quick one. 73237. Yes, each group have the same number. Priya Yadav is clear. Fatima Nuha, am I clear? Fatima Nuha. Fatima. Sorry. Okay. Fair enough. I think we can move forward. Okay. Chalo. Okay. So now if you see this problem. Okay. So see. So suppose we need to remove four elements. 1, 2, 3, 4, 5, 6. Let's suppose we need to remove second two elements, 6 elements. And we can only remove even number of elements at a time. Okay. So what I can do is I can remove 6 elements at a time. I can remove 4 elements at a time. I can remove 2 elements at a time. If we are told that we can only remove even number of elements at a time, if we are told like this, then what I can do is I can remove 2 elements at a time. Why? Because the number of operation I use does not matter to us. Okay, यहाँ पे कहीं नहीं पूछा जा रहा है कि आप कितना बार रिमूवल कर रहे हो, उससे बस मिनिमम रिमेनिंग एलिमेंट से मतलब है. Okay, the question doesn't really care, okay, in how many operation you are finding the answer. The question doesn't really care. Okay, what it cares is it cares about the resultant size. So we can easily take as many number of operation as possible. So this is the very first hint. Am I clear with the very first hint? Give me a quick one. So please refrain from making all these comments. This is a official group. Okay, like this is a place where people are learning about coding. You would be joining SD team or tech team. So थोड़ा बहुत मजाक चलता है, बट ऑफ टॉपिक मत जाओ. ओके, मतलब कोडिंग में ही हंसी मजाक करो, बट किसी को टारगेट मत करो. ओके, थैंक यू सो मच. ओके, क्लियर. Now, what I can do is, now let's suppose it is given in the question. Let's suppose we have 1, 2, 3, 4, 5, 6 elements. And suppose we remove 3 and 4. Then it is telling us that if we remove 3 and 4, then 5 and 6 should join at the end. Okay, if we remove this 3 and 4, then 5 and 6 should join at the end. This is what should happen. Okay, so now if you see this, suppose we have here 1, 2, 3, 4, 5, 6, and we remove these two elements 4 and 5. So this should just continue. How this can be done? So if you observe closely, suppose we have 1, 2, 3, and then suppose the new element is 4. So what I can do is I can just check the last element and the current element. If they both are same, then I need to remove this element and I need to remove this element also. And I need to continue doing that, and the next element should come here. 5, 6, 7. What I want to say is, translating the same in English, Hindi would be, what हम लोग क्या कर सकते हैं, हम लोग 1, 2, 3 रखे, 4 आया, तो हम लोग चेक कर सकते हैं कि जो लास्ट एलिमेंट है, सपोज 5 और 6 अभी भी बाकी है प्रोसेस करना, हम लोग लास्ट एलिमेंट को चेक कर सकते हैं. अगर दोनों सेम ग्रुप में बिलोंग करता है, सो हमें क्या करना होगा, हमें ये 3 भी हटाना होगा और हमें ये 4 भी हटाना होगा. उसके बाद 5 यहाँ आके बैठना चाहिए. Okay, 5 should come at this position. 5 should drop at this position, and this would be done. Okay, fair enough. So if you just see this, so can we do this or not? Okay, so can we do this or not? Like, we can process each elements at a time, and the new element is a new element, and we can just check if the two element, and we can remove these two elements. And this is the same removal of two elements, and the next element should follow it. So am I clear with this idea or not? Then I would explain what intuition will it lead to. Tell me quickly. Give me a quick one if this thing is clear. If this thing is clear, give me a quick one. There are 55 viewers at the moment. So is this clear? Give me a quick one. Okay, fair enough. So now if you see this idea, what we are doing basically. Okay, suppose we have here we have the array as 1, 2, 3, 4, 5, 6. And we are processing the numbers 1, 2, 3. Then the current number is 4. And we are just checking with the last number. So checking with the last number means that we need the access to the last inserted element. Okay. If they both belong to the same group, then we need to remove the element from the same group. So removal of the last element. And then after that, suppose 3 and 4 is processed. Now 5 should come here. So what we want is, the next very thing is, insert new element at the end. So if we have the access to the last inserted element, removal of the last inserted element, and insertion at the last element, insertion at the end point, then this question is of the data structure what? Give me a quick reply. Give me a quick reply. Insertion at the last, access at the last, and removal at the last. Then this question is of which data structure? Absolutely. Okay, then this is a question of stack. Okay, this problem is of stack. Now what we would do is, we would start inserting the elements. If we have no elements, then we would simply insert. And then when we have a new element, we would just see the last inserted element. If they both belong to the same group, then we would delete the last element and we would continue doing that. Now the question is of grouping the numbers. Okay, so now see what was there at that point. Yes, this thing is important. Okay, so now see, how can we group? Suppose we have a number as, suppose, 9. So what we can do is 9. Okay, 9 divided by 2 is equals to 4. 4 divided by 2 is equals to 2. So we can see that this number is of this. Basically, every number log base to n would give me the power of 2. So what we can do is, instead of 9, we can write 3 at its position. Instead of 9, we can write 3 at its position. Instead of 5, we can write 3 at its position. Okay, so we would write the powers of 2 from which it belongs. So then the problem becomes very easy. Now let us just see this. Suppose we have 7, 8, 6, and 4. 7 belongs to which group? 7 belongs to the second group. So this would be removed with 7. 8 belongs to which group? Group number 3. So this would be replaced with 3. 6 belongs to which group? Group number 2. So group number 2. 4 belongs to which group? Group number 2. So group number 2. So this just means that suppose we have 2. So 2 would be kept because the stack is empty. Then we have 3. The last number is not 3. So we would insert it also. Then we have 2. The last number is not 2. So we would insert it also. Then the current number is 2 and the last inserted number is also 2. So we would remove this 2 also and the currently processed. The remaining size is 2. So we would return this value. So first we would replace the numbers with its group. How we would replace the numbers with its group? Log base to n. Okay, we would replace all the numbers and then we would start processing. If the queue is empty, we would insert the number. If the queue is not empty, we would see if the last inserted element is equal to the same element. हम लोग क्या करेंगे, सारे नंबर्स जो ग्रुप से बिलोंग करते हैं उससे रिप्लेस कर देंगे. जैसे 7 को 2 से रिप्लेस कर दिया, 8 को 3 से रिप्लेस कर दिया, 6 को 4 से रिप्लेस कर दिया. अब हम लोग समझेंगे कैसे कौन सा क्या ग्रुप में बिलोंग करता है. देखो, एक नंबर 2 टू दी पावर कितने में है? ये 2 टू दी पावर 2 में है, ये 2 टू दी पावर 3 में है, ये 2 टू दी पावर 2 में है, ये 2 टू दी पावर 2 में है. सो हम लोग ग्रुप्स में ये कैसे बिलोंग करता है वो उसे रख देंगे. ओके, हम लोग ग्रुप में ऐसे रख देने के बाद हम लोग लास्ट इंसर्टेड एलिमेंट्स को देखेंगे. अगर स्टैक एम्प्टी है तो उसे इंसर्ट करेंगे, स्टैक नॉन एम्प्टी है तो लास्ट वाला एलिमेंट को रिमूव करेंगे. Am I clear with this idea? Now I would move forward with the implementation. Yes, absolutely. Number of bits set or powers of 2 and that would solve the purpose. Can I have a quick one if this idea is clear? Okay, just give me a minute. Okay, so I'm clear till this point. Now comes the last implementation of the last problem. So now what we would do is we would replace the numbers with its power of 2. So for int I is equals to 0 and I plus plus, basically we would start iterating, and then for int y is equals to 0, and then we would say while the number, okay, can be divided by 2 itself. Okay, and then at this end we would replace that grouping itself. Okay, it's done. After this point we would initialize a stack. So basically I need to change this value. Yep. And now we would start the iteration for int I is equals to n I plus plus, and then if the stack is empty, if b dot size, okay, so if st dot size itself is valid, like we have some elements, so what we can do is we can have something like this. If stack is empty, if the stack is empty, we would push the value st dot push the value a of I. Okay, if the stack is not empty, if the stack is not empty, else if st dot top element, if the last inserted element is equal to the current element, then what we would do is st dot pop. If this is not true, then what we would do is we would insert it. Okay, it's done. At this point the for loop would be done, and then we would return st dot size. Now let me just see if this is giving us a correct output or not. Yes, it is. Okay, it's done. Okay, so just tell me the line number and this stream would be done. Tell me the line number at this point where you are not able to understand. Okay, Utkarsh, and I'll just quickly confirm if this question is clear or not. If this question is clear, give me a quick one. Else, just mention the line number at which point you are not able to understand. Could you explain the use of the comma? Okay. Line number 16. Okay, so if you don't want to use comma, what you can do is you can simply have it like this, and that would solve the purpose. Now, no confusion about this comma and all. And this would also give you an AC. Just remove the comma. So line number 16, can you line number 16, 17? So basically, just see if the given number is suppose 8, then we would divide 8 by 2. So here we have a counter as y. So initially y is equals to 0. So 8 by 2 would make it 4 and the counter would become 1. Then 4 by 2 is equals to 2 and the counter would become 2. Then 2 by 2 would become 1 and the counter would become 3. And then 1 divided by 2 would make it 0 because we are doing integer division, and the counter would make it 4. So 8 would be replaced with the value as 4. Okay, this is what we are doing. And here we are keep dividing it and we are keeping a counter parallelly. This is what we are doing. Am I clear with this idea? Any more further queries you have, quickly tell me, else we would just end this stream. So I would be waiting for the next 30 seconds and then I would be turning off the stream. Okay, thanks a lot, Kumar Spandan. Okay, done. Okay, so I think no more queries is left. So that's it for today. So if you're watching the stream in the recorded version, feel free to like and comment the video so that the reach of this video could be increased. And if you're facing any issues, then drop your queries down in the comment section. And if you want your GFG written in React, no, GFG is not written in React. It is written in some different cases. Okay, just let me see. The tech stack use is different. It is not React. Some pages of GFG is written with React. Okay. Okay. So if you want to connect with me, then this is the LinkedIn profile. Okay. So I think that is it for today. Okay. Thank you and have a nice day. Leave your views in the comment section. Good night, everyone.